STP operations. So using the spanning tree algorithm, STP builds a loop-free topology in a four-step process. First, it elects the root bridge, then elects the root ports, elected designated ports, and elect alternate ports. So during STA and STP functions, switches use BPDUs to share information about themselves and their connections. BPDUs are used to elect the root bridge, root ports, designated, and alternate ports. And each BPDU contains a bridge ID that identifies which switch send the BPDU. The bridge ID is involved in making many of the STA decisions, including the root bridge and the port roles. And the bridge ID contains usually a priority value where the default is 32768, the MAC address of the switch, and the extended system ID, which by default is VLAN1. So the lowest bridge ID value is determined by the combination of these three fields. So again, in the bridge priority, the default is 32768. It can be arranged from 0 to 61440 and in increments of 4096 if you are to set it up. The extended system ID is by default is VLAN1. And then the MAC address, so switches has MAC address. No? So yes, so in case, usually when you have like say 3 switches, they all have the same priority number if you did not configure it. And the switch basis for the whoever will become the root bridge is the one that has the lowest MAC address. So for example, like in here, I have these 3 switches, S1, S2, S3. Looking at it, S1 has a priority of 24577, while this S3 is 32769 and 32768. 76669 also for S2. Usually the priority is 32768. They added the VLAN1, the one, so that's why it became 32769. So in here, S1 will become the root bridge because S1 has the lowest priority number. So since S1 is the lowest, is the root bridge, meaning this path here and this connection is okay, alive. So meaning this trunk 2 will be the one considered as the alternate port. So the moment that this happens, next thing happens is to know the port roles. Okay, that's the next in the agenda. It's the one that I just explained a while ago. So in the port roles, okay, so again, since this is a root bridge, usually if the example, like in this case, S1 is the root bridge, all of its port is designated. That's how it is. So this is a port role. So designated ports are assigned to the ports of a root bridge. And on the other side is root. So always the partner of the designated is a root port. It can never be like designated and designated. It should be designated and then the root port. So that's how it is. So one thing you need to take note. So again, like in this case, again, S1 is the designated since this is the root bridge and the other side is the root. So meaning this side is the alternate. Okay. So in the alternate path, only one port is being blocked. So let's say in this case is this one. So the role of this is block, BLK, okay, or disabled. So how which of these two will become the block port or alternate or designated? The switch that has the highest MAC address or priority, the one that has the highest bridge ID, say first is the priority. If S3 and S2 has the same priority, then what you look into is the highest MAC address. That's how it is. So like in this case, I suppose S3 is the one that has the highest MAC. That's why S3 port FA02 is blocked. And then on the other side, the partner of the block port is always designated. So there, so again, S3 is the alternate or block port, and then on the other side, that's the designated port. STP has timer. First, it has hello. So usually when you set up, and by default, STP is default, by default is enabled. When STP works, the switches will talk to each other. They will send BPDU. What's inside the BPDU or the bridge ID. It is so the hello time is the interval between the PBDU and the default is 2 seconds. Then we have the forward delay timer. The forward delay is the time that is spent in the listening and learning state. The default is 15 seconds and can be modified between 4 and 30 seconds. Then we have the max age timer. That is the maximum length of time that the switch waits before attempting to change the STP topology. And the default is 20 seconds, but can be modified between 6 and 40 seconds. STP facilitates the logical loop-free path throughout the broadcast domain. The spanning tree is determined through the information learned by the exchange of the PBDU frames between the interconnected switches. So if a switch port transitions directly from the blocking state to the forwarding state without information about the full topology, during the transition, the port can temporarily create a data loop. For this reason, STP has 5 port states, 4 of which are operational port states as shown in the figure. So we have the blocking, which is in 20 seconds. So like switches in STP, first it is in the blocking stage, nothing's happening, and then um, after that it will transition into a listening state where the delay is 15 seconds. Then it will move to learning. In here, like switches now are electing the root bridge and identifying the port roles, and after that, then it will now be into the forwarding state. So these are the tables of the different port states and their corresponding BPDU MAC address and forwarding data frames. And this ends this part 2 of Module 5 STP. I'd like to thank you for listening. Keep safe. Together we learn as one.